I'm going to demonstrate how to use COLMARm, the two-dimensional NMR software. COLMAR was created by the Bruchweiler Lab at The Ohio State University. COLMAR stands for Complex Mixture Analysis by NMR. Users have the option to process 1D and 2D spectra and quantify data through the various facets of the software. But I'm going to focus on COLMARm, which is used for two-dimensional querying and verification. You can access it via the link below. To begin, I'm going to type in my name and institution into this box. Now you have the option to name your experiment. I'm going to name mine red wine. Now I need to upload my parameter files. I'm going to open my files. I'm going to find where they're located on my computer. And then I'm going to click and drag them into the appropriate box. This is my HSQC file. It's going to go right here. Now you also have the option to upload a Toxie and HSQC Toxie. These are entirely optional, but they can help verify your data. For example, the Toxie parameter shows that your spins are in the same system, and it further validates your HSQC data. Once you have all these uploaded, you can go ahead and click this button. This may take a couple minutes, and when it's ready, you will see a graph appear down below. Now that my data is loaded, you can see that this graph down here has appeared. Now we can move to step 2. Up in here in this box, this is your peak picking step. I'm going to use Deep Picker Model 2. I'm going to go ahead and select this. You also have the option for peak fitting. This is what you want to do if you want to quantify your data. I'm not going to do that in this video. This will take a couple minutes as well. You will see it appear down below here when it's ready. Now that step 2 is finished, you can see that I have blue circles depicting the peaks on my graph. And so now we can move to step 3. This is the calibration step. If we look right here on my graph, I'm going to zoom in. This is my database DSS peak, and this is my sample DSS peak. These should align, but they don't, and that's going to be an issue because all my data will be shifted. So what I'm going to do, I'm going to deselect these. I'm going to hit calculate, and then I'm going to apply. So what this does is it will automatically calculate how far to move my graph over. And as you can see here, it aligns. Now that we finished this step, we can move on to step 4. So at the top here, it says chemical shift cutoff. This is how far compounds can be from database peaks before they are excluded. Now down here, we have our operating frequency, or the strength of our magnet. It is important to select the right one, otherwise your graph and data will be distorted. For my sample, I'm going to use the hydrophilic metabolite database because I'm using red wine, and I'm going to go ahead and submit. This will take a couple minutes, but when it's finished, you'll see your compounds appear when it's ready. Once finished, your graph will change and your compounds will appear down here below. Here are all the compounds in my sample. This table right here depicts some more information that you can use to take a closer look at your data. Now, if you scroll down to the bottom, this is another list of the same compounds. I want to take a moment here to define what the matching ratio is. The matching ratio is the number of match peaks over the number of total peaks. If this value is too low, that may indicate that your compound is not present in the sample. As a general rule of thumb, your matching ratio should be above 0.6, and even then you will need to double check this to make sure that your data is correct. Fortunately, COLMAR makes this very easy. I'm going to select L-proline right here. Now you have the option to come up here to this graph and manually check your data. Or you can come down here. These are your parameter graphs. This is HSQC, this is your Toxie, and this is your HSQC Toxie. I'm going to increase the plot size. and I'm going to increase the zoom scale. You should be cautious about increasing the zoom scale because it'll make differences between the experimental and database appear more drastic. You should keep in mind your axes when you make your decision. So for my HSQC graph, these green dots are the experimental matched peaks, these red circles are the database peaks, and then these blue lines are the Gizmo database reconstruction of the spectrum. So what you can tell from this graph is that my green circles are really close to my red database peaks and are actually inside of the spectrum from the Gizmo database. What this means is that it's very likely that this compound is in my sample, but I want to verify it before I make any final decisions. So I'm going to come down here to my Toxi graph. You have the option to mess with contouring, but I'm going to keep it up here. That way I can still see everything. But what you notice is that these red database peaks line up really nicely with the spectrum. These magenta circles are my expected cross peaks, and you can see that they also line up really nicely. So what I'm going to do, I'm going to come down here to my HSQC Toxi and triple check. I have my expected cross peaks, and I have my database peaks, and they all seem to appear somewhere in my spectrum. So I think this compound is definitely in my sample. I'm going to come up here, and I'm going to select good, and it'll automatically move to the next one. I want to show an example of what a bad compound would look like. I'm going to go to UMP. What you see here is the HSQC graph, and these red database peaks, they don't have any matching peaks in my experiment. So that's not a good sign. I'm going to double check my Toxi, and you can see that I have a lot of cross peaks that just don't line up with anything. If we look at my HSQC Toxi, you see the same thing. So what I think is that this compound is not my sample, so I'm going to select poor. You should go through each compound individually and double check and make sure everything lines up correctly. Once you finish, you can come up here, you can select your classification, and you can show the matched compounds. These are all the compounds I selected as poor. You can do the same thing with good as well. Now, once you finish, you need to be sure to come down here to this area right here, and you'll want to save revised query result to the server. This is how you will save your data so you can return to it later. You also have the option to save your compound list for COLMARm if you want to be more precise. Now, if you want to return to your session, you're going to scroll down here to the very bottom, and this is your session ID. You want to copy and paste this, and when you open a new session of COLMARm, at the very top, you will see this space right here. You will paste your ID into here, and it will load all of your saved previous results. That concludes the COLMARm tutorial.